If you want to level up your skills with .NET and Blazor, you've come to the right place, my friend. This video is an exclusive 3-hour preview of my Blazor and Clean Architecture Masterclass. And here's the best part. If you want to jump into the full Masterclass, I've got a massive discount just for you. It's only available to the first 100 people using the link and the coupon code in the video description below. Once these spots are gone, the offer disappears, so don't miss it. Go ahead and check out the video description below for the details. And if you're ready to level up, don't forget to hit that like button, and then let's jump into the preview of the Blazor and Clean Architecture Masterclass. Hello there and welcome to the Blazor and Clean Architecture Masterclass. I am so thrilled to have you. In this course, we're going to build a modern web application together step by step. We'll start simple, setting up your tools and creating your projects. And then you learn how to organize your code with clean architecture, work with databases using Entity Framework, add logins and user roles to keep your app safe, and make it look great with Tailwind CSS. But this course is more than just building features. You'll also learn how to keep your code clean with CQRS and Dependency Injection, and how to design smooth interactive UIs with Blazor and its new render modes. And by the end, you'll not only understand these concepts, you will also have the confidence to build real-world web applications you can be proud of, whether for yourself, your job, or your clients. Now, I know starting something new can be overwhelming, but don't worry, I will guide you every step of the way. Each lesson is hands-on, practical, and easy to follow. Plus, I've included source code downloads and quizzes to help you practice what you've learned. One more thing, this course was built using .NET 8, but it is fully compatible with .NET 9. So whether you're using .NET 8 today or planning to upgrade to .NET 9, everything you learn works seamlessly. All right, so let's get started. In the next lecture, we'll set up your tools and you create your first project with Visual Studio. See you there and happy coding. Hey there, quick info regarding .NET 9. We started this project here, the complete Clean Architecture Masterclass, with .NET 8. So the big change in .NET 8 compared to .NET 7 was the render modes, the new render modes in Blazor. You could decide if you want to use Blazor Server, WebAssembly, static server-side rendering, or the auto render mode now in one project. So you did not have to decide upfront, do I want to use WebAssembly or server, for instance. This was the case with .NET 7, but with .NET 8, this was the big change. It was confusing for a lot of people, maybe still is, for me also sometimes, but the rest wasn't that big. The changes haven't been that big. Now .NET 9 is released. By the time of recording this video, it was released 2 days ago, but there haven't been big changes compared to .NET 8. So we still have the render modes. There are a few little changes. They're not really changes, some additions, let's say, some improvements, of course, regarding performance and the static server-side rendering mode. But the most important fact here is that when you're just starting out and you want to build the same project, the same application that we're building in this masterclass, feel free, go ahead and use .NET 9. Everything should work exactly the same way as you see it here in the masterclass. If not, please tell me that, send me an email or write a post in the community or message me or everyone else in our Discord server. More than happy to add updates, add new lectures where something is not really working with .NET 9. But as far as I know, everything should work just fine. And by the way, if you already did everything with .NET 8, scroll further down in the curriculum and there you will find the update to .NET 9. So how would you update this application with .NET 9? It's really not much. So again, go ahead, use .NET 9 as your target framework and everything should just work. So happy coding. All right, now the very first thing, of course, that we have to do is downloading and installing the .NET framework and also Visual Studio 2022. I use the Community Edition, which is available for free. And same thing, of course, for the .NET SDK. So if you haven't already, easiest way to get it is simply Google for .NET SDK, for instance. Then you should have the first hit here that leads you to the download page of .NET .8, the .NET SDK. As you can see, in my case, I'm using Windows here with a 64-bit processor. So you can just download the SDK there, install it, and you're good to go. And the IDE that we're going to use is Visual Studio 2022. So again, you can just Google for it if you haven't installed it already. And again, the first hit leads you to that page, and then scroll a bit further down, and here you see it, download Community 2022. The Community Edition, as you can see it here, free for individual developers, academic use, and open source. And you can even use it for commercial purposes. So this is everything you need. Everything is available for free. Later, when we use databases, then we will use SQL Server Express. This thing is also available for free together with the SQL Server Management Studio. But again, this is then later in that course. Now please download and install the .NET 8 SDK and also Visual Studio 2022. So now the next step already is creating our application. Now in this program, in this course, we're going to build a blog application. This might sound simple, and the simple part is great for learning in my opinion, but this can be more complex later on. And since we are implementing the clean architecture, then I think you will see real early in this course that maybe a blog application is a good fit because it's easy to understand, so we can focus more on the actual architecture, the implementations, and so on, and we do not need a complex application for that. Anyways, Visual Studio 2022 is installed, as well as the .NET 8 SDK, so we create a new project. And if you've already watched the Jumpstart course or the Jumpstart sections regarding Blazor and .NET 8, maybe you think that we start right away with the Blazor web app application, the Blazor web app template here. But since we're going to use or implement a clean architecture, we do it actually another way, because we start then with a blank solution. With the help of the blank solution, we can choose or create other folders, choose to create other folders to structure our whole solution a bit more. And additionally, we can then add more projects, class libraries to be more precise later. And these projects then will represent the clean architecture, meaning the different layers that we want to use there. Anyways, first thing, the blank solution. If you don't have it here in your recent project templates, of course, you can just search for blank, for instance. Don't hit enter, just search for blank, and then you find the blank solution here as well. And as it says it here, create an empty solution containing no projects. That's exactly what we want. And in my case, the location is development, and the name for this thing then would be, for instance, the Blazing blog. So this is our project that we will create here. And when everything is done, you see nothing is there, but the first thing we do is we add not a new project. We first create a new solution folder and call this folder src for source, because this then will be the place where all our source code will be. And if you decide to add testing projects for unit tests, for instance, then you would create another solution folder called tests. And then in that source folder, we add finally another project. In here then we choose the Blazor web app. If you don't find it here, you can, for instance, just filter by Blazor, and then you see directly a project template for creating a Blazor web app that supports both server-side rendering and client interactivity. More about that in a minute. This template can be used for web apps with rich dynamic user interfaces, UIs. So everything we need, this is what we want to learn here, the Blazor for the Blazor web app for the front end, and lots of other stuff for the backend with .NET. Anyways, let's just hit next. Now, regarding the naming, the first thing already that is important maybe to structure your application or your whole solution, and also other fellow developers and your future self will thank you if you give these things proper names. Now, you have several options. As always, a lot of decisions are up to you. We already called our solution Blazing Block, and in the clean architecture we have several layers like the domain layer, application, infrastructure, and also the presentation layer, or sometimes also called web UI, because in the presentation layer you will find the entry point for your application. This can be a simple .NET Web API, so still pretty much only back-end stuff, or as in our case, we add a Blazor frontend there, so a real client web application. Now, what you can do is you can either choose to name this thing presentation, for instance, and that's it, or to be a bit more precise, maybe we call this thing web UI, because this is what it is. In essence, this is our web user interface. Now in Blazor and .NET 8, things are a little bit different now to .NET 7. This means we will start with one project, one front-end project, the Blazor server project in essence, but later then when we want to add WebAssembly, we will have another project, the client project. So it would make sense to name this now webui.server, for instance, because this is the first thing that we will create here, the Blazor server project. We are still on the server, we are starting with server-side rendering, so I guess this would make sense. Again, later when we add WebAssembly, then we can name this project that way. And additionally, what we can also do is, and what you also often see throughout the web or in professional projects, we name the project, or we give the project the same name as the complete solution. So the complete name then would be blazing block.webui, and in our case now .server. And this thing here, this is really special to our Blazor web UI presentation layer, because the other class library projects then that we will add are simply named domain, application, and infrastructure. But now let's focus on the Blazor web app, the Blazor client. So blazingBlock.webui.server is the name that I would choose. Again, things are up to you as always, but I think this totally makes sense. We hit next, and now comes the important configuration. Again, if you watched a couple of .NET 8 Blazor stuff as the Jumpstart course here in the .NET Web Academy, for instance, then you know that here you can choose several interactive render modes. But let's forget them for a sec. I just assume that you're totally new to all that stuff, so let me go through that one step after another. It's not much, really. The target framework now should be .NET 8. In case you installed the .NET 8 framework, of course, it should be .NET 8's long-term support. This is nice because regarding .NET 7, support is, or was, depending when you're watching this, it was only supported until May 2024. For .NET 8, this is way longer. Now, regarding authentication, we could add authentication already with individual accounts, but I think for the beginning of our journey here in this course, this might be overwhelming. It is great later, for instance, when you want to build an application quick and you want to use the ASP.NET Core Identity Framework, then you can simply choose individual accounts and you get lots and lots of boilerplate code out of the box that you can totally use. It's great stuff, but if you're just starting and you want to learn all that, I suggest forget about authentication for a while, choose none, and focus on other stuff. Configure for HTTPS is great. That's not that complex. It just means that, well, we are forwarding all the requests to HTTPS, more secure, great stuff. And now comes the interactive render mode. Again, I talked about that a lot already, but here you see 4 choices. None is the one that we will choose here at the beginning. Might be wondering, why is that? When you used Blazor before, or you just heard about Blazor, then maybe you heard a lot about Blazor Server and in particular Blazor WebAssembly, using WebAssembly and so on. This is the great stuff of Blazor. Yes, totally true. I'm totally with you. You're absolutely right. In particular, Blazor WebAssembly is something that I learned to love a lot, but with .NET 8, things changed. Not only a little, you can still use it as before, But the entry point really is the new so-called static server-side rendering. This means, in short, it's Blazor SSR, but the .NET Core team decided to use the term static server-side rendering, so it's not that confusing then to Blazor server, because server is also server-side rendered somehow, right? So static server-side rendering means that everything is created on the server, and the server then sends the already rendered, the finished HTML down to the client. And this is really interesting because lots of applications, for instance, our blog, can make use of SSR a lot. So there are, as you will see, not a lot of situations where you really need interactivity that is used with Blazor Server or Blazor WebAssembly. You can already do a lot now with static server-side rendering and Blazor. Again, great stuff, but of course we will have a look at all render modes, so I don't want to dive into the other render modes for now. Just know Blazor Server is like the old server using WebSockets. Blazor WebAssembly, as the name implies, uses WebAssembly, so you download the files first to the client, so you might have to wait a bit longer. But then you have interactivity on the client. No internet connection is necessary. This is different now with WebSockets, of course. There you have to have a constant internet connection, and auto means you will use both. First, WebSockets for quicker or shorter loading times, and then the WebAssembly files are downloaded in the background. So the next time you visit the page, then WebAssembly is used. This is just really quick introduction and summary about these render modes. But again, I want to use none here, so static server-side rendering only. Next is the interactivity location. Now in this course, I want to use per page and component because in my opinion, this makes more sense, in particular when you're learning that. This just means that you can decide for every page and every component which kind of render mode you want to use. If you choose global here, then this is similar to the old world before .NET 8, meaning that if you choose, for instance, server and then global, then you get a solution that is already configured to just use WebSockets in the complete application. So the WebSocket connection is always open. Same for WebAssembly. You have to download all files first. The user has to wait until everything's downloaded, and then you use WebAssembly for the complete application. Again, if you're used to developing Blazor applications that way, then maybe you want to choose that as well. But if you want to learn the new Blazor universe, let's say, then maybe you want to choose none here, and then per page or component, because just a quick example, if you choose WebSockets, meaning Blazor Server later, then you will see that a WebSocket connection will be opened for a particular component or a particular page. But when you leave this page, then the WebSocket connection is also closed. So you save lots of resources there, for instance. Include sample pages, yes, so we can have a look at how this application looks, and do not use top level statements. We can leave it as it is. So now, long story short, let's just create that thing, and there it is already. And with that, let's have a quick overview of the most important parts of this new project. So our project is created. You see we have some folders here, right? Again, if you already know Blazor a lot, it looks a bit different now. Layout folder, pages folder, the names of the files is a bit different. So let's just go over them, or the most important files, real quick. I'd like to start with the AppRaiser file. Maybe we close the Solution Explorer here. As you can see now, this is the root component of your Blazor application. It is structured like an HTML page. You see it here, doc type, then the HTML tag, and so on. So typical elements also, such as the head and the body, are there. Additionally, key elements include the base href. All right, this sets the base path for the application. Then we see a couple of link tags here. Now these include CSS files like Bootstrap, which is default when you use the example stuff. and app-specific styles and other custom styles if you want. You also see the fav icon here, stuff like that. Then already interesting is the head outlet. So this is a built-in component of Blazor, which is a place for dynamically updating the document head. This means, I think the easiest thing to remember is the page title. So when you open a certain page, then you see the name of the tab or the window of your browser then is or can be different, and this is rendered with the head outlet. Another way to look at the head outlet might be documentation here. As you can see, control head content in a Razor component. You can also define head content like meta tags here, the description, for instance, of your page. And here it says it, the head outlet component renders content provided by page title and head content components. So this is what the head outlet is for. If you hover over that, you see pretty much the same explanation there. So just so you know, this is what the head outlet is for. Not that important for us right now. More important is the routes component. Now this is where the router will render the matched component. We will have a look at this thing in a minute or in a sec. One more thing I want to mention here is this line. This is very important because this is the script necessary for Blazor to run, in essence. All right, so this is the app Razor, and now next let's have a look at the routes already. Now, as you can see here, this file defines the routing for your application. Now, the router, this thing here, is the component that enables routing in a Blazor app. And the app assembly here specifies the assembly to search for components, usually your entry assembly. And as you can see here, it just grabs the assembly from our program CS file down here that we will also have a look at in a minute. Next is the found component, this thing here. And this one specifies what to render when a route is matched. So if you, for instance, just enter a certain route in the address bar of your browser, or you click on a navigation link, then this component kicks in, and then comes the route view, which renders the component corresponding to the matched route, and it uses this default layout. Then, as you can see here in the layouts folder, we find the main layout. We will have a look at this thing as well in a minute. So that's how this works. Route view kicks in when a route is matched, and then uses the main layout to display the content then of this page, and focus on navigate. As you can see it here, after navigating from one page to another, sets focus to an element matching a CSS selector. This can be used to build an accessible navigation system compatible with screen readers. And in that case, it's the H1 that gets the focus. All right, so far the routes Razor. Now, pretty simple, the imports Razor file. This is a global import file for commonly used namespaces, so you don't have to import them in every single component. As you can see, it includes namespaces for HTTP, forms, routing, JavaScript interop, and of course your own namespaces, like in our example here, the Blazing Block Web UI server. So whenever you use or create a component and you want to use a specific service, anything like that, a specific entity, for instance, also, so meaning specific classes that you will find in other projects, for instance, then you can either choose to add the using directive in that specific page or that specific component, or you just add the complete line to the global imports Razor file here. If you're familiar with global usings in .NET in general, it's pretty much the same thing. Okay, you have one file where you can put all your usings, and that's it. One more thing I want to mention here is this specific line. This is new to .NET 8. This is necessary to or for the render modes to make them work, because you will see there is this new render mode directive that is used to specify, well, the render mode for your component or your pages. And this using directive here, this reference is then necessary to make this work. All right, so far the imports Razor. Now let's move on to the main layout Razor as promised. Now this thing defines Well, the main layout of your application. As you can see, it inherits from a layout component base, and this is pretty much how this already works. If you want to create your own layout, so change the complete look of your application, you just create another Blazor file and inherit from layout component base, and then you can do whatever you want to do with that file. There's just one important thing you have to remember. Well, first, in this specific main layout, you see regarding the structure, we've got a sidebar here, right, with the nav menu, the navigation. Nav menu is just this component here that is provided by the example template here. So this thing uses then the built-in component, the nav link, as you can see, a component that renders an anchor tag, automatically toggling its active class based on whether its href matches the current URI. So in essence, this is just a link that you can click in the navigation bar, the sidebar in this particular example, and then you navigate the user to the specific page, like the weather page. We'll have a look at that in the next lecture. But the more important thing really is this line. So add body. This is a placeholder where the content of the routed component will be displayed. So when you create your own layout, two things you have to do: inherit from layout component base, use the add body. We could, for instance, remove everything here, everything HTML related, just add the add body here. And then, as you see it here, it returns then the render fragment, which is then in essence, in simpler terms, just the page or the content of your specific page. See, there gets the content to be rendered inside the layout. And of course, if you already want to change your layout, you have to go to your routes Blazor file and then also change the layout there. All right, so that's that. I think the other things are not that important except the program CS. Real quick though, you see the properties folder with the launch settings. So here you see some configurations, for instance, regarding the application URL. So this is where we will find our application when we run this. You also see the www root folder with CSS style sheets. This might be important if you want to change the styles globally. You see your fav icon there, and also by the example template, the provided Bootstrap framework here, so that we can design our buttons, for instance, a bit prettier maybe. And then also the app settings. This will also become more important later when we use Entity Framework, for instance, to connect to a SQL Server database. Then we will see the connection string in here. You also see logging information. You can actually store or put lots of configs and information there in the app settings JSON file. And the great thing is when you then deploy your application to Azure, then Azure knows, or you can add the for instance, a connection string or other configurations from your app settings then there to Azure, and then this just works, meaning that when you run your application locally, then it grabs the info from your app settings JSON file, but when you then run the application or deploy the application to Azure, then Azure grabs the information not from your app settings JSON, but then from another place that is configured in Azure. All right, enough about that, I think. And enough about the other files here. We will run the application in the next lecture and then have a look at the home and the weather pages here. But now the last and also, of course, very important file is the program CS, because this is the entry point of your application, configuring and running the Blazor app. Now, the first thing, web application create builder. This sets up a builder with default configuration. Later, we can use the builder to register more services, register the database context when we use Entity Framework. And as you can already see here, add Blazor components. This adds services required for Blazor components. As you can see here, required for server-side rendering of Blazor components. Later, again, when we use the other render modes, then we have to add more functions here for Blazor server or the server interactivity render mode, and also the WebAssembly render mode. And the same thing down here, we have to add more stuff to make this work. But so far, since we're only using static server-side rendering, this is totally sufficient. Then after that, we see the HTTP pipeline configuration, including like exception handling here, HTTPS redirection, and serving static files and anti-forgery measures. You can always hover over the methods and you see a small explanation here. As you can see, enable static file serving for the current request path. And here, anti-forgery middleware to the pipeline is added. This will be important when we use forms with static server-side rendering, for instance. And then down here, this maps the page components defined in the specified app to the given assembly and renders the component specified by app when the routes matches. So it maps the root component, the app, to the, in our case now, server-side Blazor app. And again, later when we use Blazor server or the server interactivity render mode and the WebAssembly render mode, then we have to add more functions here as well. Okay, so I think this was already a lot. Now you have an overview of all the files in this particular project. And I would say again, in the next lecture, let's just run this application and play around with that a little. All right, now when you're using Visual Studio, you see you have two play buttons here, right? This is the first one, which has here by default configured HTTPS. And when you click on this thing, then the debugger will run. And I don't want to start the debugger here because it takes a bit more time, a bit more complex, but you can also choose this thing here. So start without debugging, and you can then keep things running. And when you change something, you can either choose to use hard reload to, well, reload the application in the background when something changes, or what you can also do, now you have it here, again, hard reload, and you can choose to use hard reload on file save. Honestly, I switched to using this button here, restart application. So whenever I change something and I'm thinking, okay, now I have to restart the application, then I just do it manually, because the hard reload, for me, it still is, it was and still is a bit confusing. Sometimes it works, sometimes it doesn't. When you change little things like the styling of your page, then it might work really fast. That's great. But often you have to restart your application anyways, because you make so-called root changes to your application. And in that case, I just choose to disable hard reload on file save and just restart the application manually when I think it's time to restart it. And here it is. So you see, this is our URL with the port 7197. Just have a look here. I already told you in the launch settings, you see the URL, and that's the HTTPS case. And you see application URL, HTTPS localhost 7197. So this is really our entry point, and it already uses the environment development. All right, so that's that. And the other thing that is important is we only have the weather page here. If we would have chosen to use Blazor server or WebAssembly, then we would also have the counter page here to demonstrate interactivity already. But again, I know I'm repeating myself, but we do all that later. Now, the more important thing is really this weather page. And here you can already see how a Blazor application works. It's all about components. You see here the home razor. Again, how does it work? We have our main layout, and here now in the body, when the URL matches, in our case it's just slash, it's the root of our application, then it knows with the help of this directive here that we're on the root. And also what you can see here now is, talked about that earlier, you see the page title component, again a built-in component, and you see it here already, it enables rendering an HTML title to a head outlet component. So we have again our head outlet here, and when we use the page title, then it changes the page title in the head outlet. And when we have a look again at our browser, we see weather now is the title of our tab. And we go back to home, we see home, and that's pretty much it. All right, so this is the text. When we change that to, I don't know, home page, for instance, restart the application manually, we will see now this is called home page. pretty simple, and that's how that works. Okay, the rest is default HTML, I'd say, but the more complex one is the weather razor page. Again, we have the page directive here with the weather route. When we go here, we also see the route. It matches that thing. And then we have a couple more things going on here. So let's dive into that real quick. You see, with Blazor, you have an HTML part, which is this thing, also mixed with a little bit of C#, which is one of the many great things of Blazor. So you can use C# together with HTML, and as you can see, we can already use an if clause here. We can use a for each loop, and the actual code then that is used or necessary for the code that's used on top here in the HTML part is, or in the markup part, let's call it that way, is the add code block. Now you can also decide to use a code behind file if you don't like that look here, right? For that, what you would do is you would go to your pages folder, for instance, and then add a new item and just call that weather.razor.cs, add this thing, and here you already see it is added below the weather razor file, and you see the weather class here, and then you can choose to add your logic in there. I told you that already. Many things are up to you, and if you want to do it that way, then please do it that way. I'm not a big fan of that way, code behind files. I like to see everything directly on my weather razor page and hopefully keep things small. So this is why I choose that way to implement and develop my Blazor applications. Anyways, what we now see here is first, if forecasts are null. Now, where are these forecasts? Well, these are here. So you see in your code block, typical C# stuff, we can define our forecasts. And what we also have is the weather forecast class, and this one is also put in here. Of course, we will make this a bit different. We will put entities, value objects, any kind of classes in different projects, layers, and so on. I want to use clean architecture here, so we will improve that. Now, the other thing still I want to show you here already is the onInitialized async method. And now, what is that? This is one of the lifecycle methods of Blazor. There are three main lifecycle methods. We've got the onInitialized async, and additionally we have, let's just have a look here real quick, protected overrides, and then you will see onInitialized. There's also the async part then, so onInitialized async, and then we've got onParameterSet and onParametersSet async and onAfterRender. And the order is really onInitialized first, then onParametersSet, and then onAfterRender. So this means whenever we start or whenever we open a component, then we can decide on initialization. So when this component is initialized, we can run some code. Then we can decide after some parameters have been set, we can run some code. And then the last thing, when the component has been finished with rendering, we can run the onAfterRender and run some code in there. Now here in this specific example, what Microsoft did is they simulate loading data. So similar to an API call or just calling the database for some data, they added a pause here of 500 milliseconds, and then they just created random weather forecast data. Now, why did they do that, or why did they choose to do that? Well, they want to demonstrate the stream rendering here. And this is already magic of the new magic of the static server-side rendering. Let's have a quick look at stream rendering and how, in general, rendering data with the new static server-side rendering in the next lecture. All right, so we have the attribute stream rendering here. When we open or just run this application and we open this page, we see the loading text and then the data here. Okay, now what happens if we remove or just comment this line out and restart the application? We see it's rebuilding, and now where is the loading text? It is not there anymore. And what happens if you go to home, and then when I go back to weather, pay attention to the address bar, the route will change, but the data will come pretty much half a second later. See that? One more time, I go to weather, weather's there, and then comes the data, and I don't see a loading text. I think you already know where I'm getting with this. So stream rendering means that you do not have to wait until the data has been finished loading. Let's make this a bit more extreme and, for instance, add 2 seconds here, right? And now restart the application, and then you will see it is now rebuilding, reloading. Well, we are already on the weather page, so we do not really see an effect. But when we now go to the home page, now I click on the weather URL, and then you see that the address bar has been changed. The URL has been changed, but the data comes pretty much 2 seconds later. Another way to demonstrate that is, of course, when you open the developer tools and then go to network. Let's just go to all, for instance, and then we go to home. Then we clear everything, and now we go to weather, and you see it is pending and pending, and then we see finally here, and regarding the time, we see pretty much exactly 2 seconds. Now again, what happens if we go back to 500 milliseconds? We restart the application. Now we are already on that page, and we still see pending. Well, this was a bit longer because the page was rebuilding. So let's go back to home, and then we back to home. Now we are there, and now we go to weather again, and yeah, a bit longer. We now have 575 milliseconds. Okay, so you see really this is the simulated delay. And now what happens if we add stream rendering again? So maybe 2 seconds here, and stream rendering activated. Save this, restart the application. Again, we are on the weather page, so maybe we can change that in a minute or a second. So back to home, and now I go back to weather. We directly see the page, and the data comes a little bit later. So here you see regarding the timing, we see that waiting for server response is only 56 milliseconds, but the content download took 2 seconds, right? And this is now the big difference. Let me do that one more time. I'm repeating this because this is really important, in my opinion. One of the most important factors really about the new static server-side rendering. When we have a look again, let me just clear this, go back to home again, and then switch to the weather page. And we go here, you see initial connection, and now you see that waiting for server response is 2 seconds, and the content download only 0.4 milliseconds. Okay, so this is really the big difference. And the magic you see here also is when you see the preview, that we already see the data here. So we have to wait for the server to finish rendering the complete result, actually finish getting the data. But with stream rendering now active, we do not have to do that. We can, for instance, display the loading text, or you would see some mock-ups there, you know, that flashing effects, in that case, a flashing table, something like that. And then you see that the actual content that is downloaded first is also different. We first see the loading text, and then here again regarding the timing, we see now the 180 milliseconds is because the complete app was rebuilded, but then it took 2 seconds to download that thing. Again, this is different when we just switch between the pages one more time. And here we see 33 milliseconds and 2 seconds to download the data then. So this is the magic of stream rendering already. And again, here is the loading text, right? So this is how they showed it to us. The forecasts are null in the beginning with a nullable weather forecast array here. And when the weather forecasts are set, then it gives us the table with all the data. Okay, so far a quick introduction to Blazor and our Blazor web application with static server-side rendering. And now the big question is, what's next? Do we continue with our Blazor application, or maybe do we implement or add something else? Well, let's have a look in the next lecture. All right, now let's outline our roadmap a little. We've started with the Blazor web app to give you an immediate hands-on experience already. But now let's dive into more advanced and structured approaches in web development. First, an introduction to source control. So our first step is understanding the importance of source control. Now, why is that? Well, because code is not just about writing, it's about evolving and collaborating. Git and GitHub are essential tools for that. They help us manage our code versions, collaborate with others, and maintain a history of our progress. And this is what I really want to emphasize, the history of our progress. So also, when you're developing something completely by yourself, of course, it makes so much sense to already use source control like Git or GitHub, so you can always go back, you can structure your implementations, you see your so-called commits, so all the steps that you did, you can use feature branches to test something first, test other implementations first, all that stuff. We will also make use of that in this course. So please, please, please use source control for your application. It is really crucial for any professional development environment. Then next, we will already introduce the concept of clean architecture. Now, this approach is all about organizing code in a way that separates concerns, making our applications more maintainable, scalable, and adaptable to change. Clean architecture helps us to define clear boundaries and responsibilities within our code. Now, that said, in small to medium-sized projects, clean architecture might be overkill. But I guess you are here to learn something, and maybe you want to create bigger applications. So that's why I think the clean architecture approach is definitely the right one here. But as you know, we began our journey with Blazor. It's really powerful, but it's just one piece of the puzzle. So again, as we move forward, then we will integrate it into a more robust architectural framework. And for that, in the upcoming sections, again, we'll have a look at clean architecture and also explore entity framework for database access. We dive into the service pattern and learn about CQRS for CRUD implementations. Now, one note on that already. You often see clean architecture combined with CQRS and Mediator. Please bear with me if you haven't heard these terms before. Of course, I will explain everything later in this course, but you can also use clean architecture with services only. So I want to compare both approaches because I think it is a lot easier to understand these foundational concepts for modern web development then. And later, we'll also add authentication features with identity, we integrate payment systems like Stripe, and enhance our blog project with more advanced features. But before we dive into these new topics, our immediate next step is to ensure our code is safe and well managed, and that's why we're turning our attention to Git and GitHub next. All right, now welcome to the Git and GitHub section here. Now, the very first thing I recommend is you, again, use Google to search for Git, and then you'll find the first hit here, which is Git, and you go there, download Git and install it if you haven't already. As you can see here, it is easy to learn, it says at least, and has a tiny footprint with lightning fast performance. It outclasses SCM tools, source control management tools like Subversion, CVS, Preforce, ClearCase, and so on. So let's just go to Git, and one fun fact, maybe it is created by Linus Torvalds, so the creator of Linux. He thought all the other tools are not that great, so let's just create another one, and now the whole world is using Git. This is just crazy to me. So here it is, Git, and of course you can then go to downloads. In my case, again, download for Windows, and if you, or when it is installed, then you can use it locally. But then again, I also recommend using GitHub for your source control, meaning that you may want to push your code to the cloud. But then again, if you don't want to do that, of course, you can also use your own server or just do everything locally, store your repository somewhere else. That's again totally up to you, but this is what I recommend, since the whole development, not only web development world, maybe game development is a bit different because of the binary files, but regarding web development in particular, pretty much everybody is using Git nowadays. So please just go there, download it if you haven't already. And then the next step would be to create your GitHub account. And then we will create our own Git and GitHub repository with the help of Visual Studio. So let's have a look at GitHub next. So there it is, github.com is the URL, and you see let's build from here, the world's leading AI-powered developer platform. Now AI, of course, is the modern stuff that everybody is talking about today. Here with GitHub, you get the GitHub Copilot. Nothing we will have a look at. Of course, if you want to just have a look, it might help developing your applications, but we're doing everything on our own. One interesting thing though I want to mention here is GitHub Actions, because this is one thing that we will also use. Maybe it's a bit too much for the beginning of this course here, but with the help of GitHub Actions, we can implement so-called CI or CD, meaning continuous integration or continuous delivery or continuous deployment, meaning that whenever we implement something, we are done implementing something, and then we commit and push something to our GitHub repository, so meaning storing our code there, then this automatic pipeline may run, and with the help of GitHub Actions, we can then deploy our application to the cloud with the help of Azure, for instance. So this is also one big advantage if you choose to store your code with the help of GitHub. So very interesting stuff. Please sign up for an account. One thing I also want to mention is if you are in the corporate world and you are not sure if you want to deploy your or store your code in the cloud, as you can see here, there are different pricing options, and that's one thing you might want to consider using if you are in a company, you're not sure, do I really want to store my code in the cloud? Security, first term here, when you're using the enterprise version, right? So again, as many things, it's totally up to you. You see also when you compare the continuous integration minutes per month that you've got a bunch more here. When you choose to use the enterprise pricing model, same thing for the storage. GitHub Advanced Security here again, premium support. So maybe this is interesting for you if you want to have a look and use that for your company. But then again, you can still use Git if you don't want to use GitHub locally or on your own server, whatever you want to choose there. But if you just want to learn Git and GitHub and you want to use that for your private projects, for instance, you see there's of course this free option, the basics for individuals and even organizations. So also possible, of course. So again, I really recommend to sign up for an account there, and then with the help of Visual Studio, we can create our own GitHub repository. If you have an account, then you see with this URL, this is my account, for instance. One example, you see your repositories then there, and you also see, if that's interesting to you, when you committed something, all the commits you did, and then you can go to your repositories, and in my case you see one preparation for the Blazor blog application here, the time tracker from the other course, and lots of other stuff. In my case, code for my other courses or my YouTube videos and so on. So this is how this looks, and in the next step then we again will create our Git repository and also already push our repository then to GitHub. So make sure to have an account ready, because then you are able to push everything to GitHub yourself. To create your GitHub or Git repository, what you can see here in Visual Studio is this button down here, Add to Source Control. Now, to make this available, I had to stop the application. So if it is still running in your case, just close the terminal, for instance. And then I also had to restart Visual Studio. Maybe this is what we have to do sometimes for the very first time when you're creating a new project. Then maybe if you don't see the button here, Add to Source Control, then you have to restart Visual Studio. Another option would be to go to Select Repository, because this button is probably available. And then you see the three-dot menu here, and then you can say Create Git Repository, or you go to Git Changes, and then here you also see Create a Git Repository. So you see there are lots of ways to do that. My usual way is really to just go to Add to Source Control, and then I go to Git, and then you see a couple of options here. First, what you can do is just create a repository locally. And with that, you already have all the benefits of Git, meaning you have your history. Whenever you commit your changes, then you see what you've done. You're able to create branches, feature branches, or branches for fixing bugs, whatever you want to do. So you can do everything locally here. And you can also use an existing remote. This means, for instance, you don't want to choose GitHub or Azure DevOps. You have your own server or just any other service provider for your source control. Then you can enter your remote URL here. One other provider I really like is GitLab, for instance. So if you want to choose GitLab, or if you choose Bitbucket, for instance, these are two big names, then you can also choose to just use the URL, meaning you create a repository on your or in your provider there, meaning GitLab, Bitbucket, whatever you want to use, and then you enter the URL here, and then you can connect your application here with Visual Studio with that Git repository. So lots of possibilities here, as you can see. Then you've got Azure DevOps and also GitHub, and GitHub is what I want to use here. You can see the local path, development blazing block in my case. Git ignore template, this is very important, because what this thing does is it tells Git to ignore certain files and folders. For instance, if you run your application, then you will find folders there like the bin and the objects folder. Let me show you that real quick. So here's the folder, development blazing block, and when I go into the web UI server, then you see we've got the bin folder, for instance, debug.net and so on. So all the files that have been created after compiling and running the application, or also here the object folder, stuff you don't want to see in your Git repository, because this is not necessary to build the application for the first time. So you don't have to store that, and even worse, could be the case that these files changes after running the application a couple of times, and Git is then recognizing the change and wants to commit this, although you did not really change your code, and this can be really annoying. So a git ignore file in this case helps. You will see this in a minute when this thing is created. There's lots of other stuff, not only the bin and the object folders, other files as well, preference files, for instance, for Visual Studio or Visual Studio Code if you want to use this IDE. All that stuff is not committed to your repository because it is not necessary, and can be annoying because they might change a lot, although again you did not change your code and you don't want to commit or push that code, or you don't want to store the history of that change then in your repository. I hope you get what I mean. Now the license template, I leave that up to you. You can just look that up. Really depends on your personal preferences. Then we can add a README file if you want. I'm not adding one here now because it's not really necessary, but just so you know, for instance, if you want to create a repository publicly or even private, and you want to just tell your future self what you can find there, or some instructions how to run this thing, then you would typically put that into the README file. And then it comes to GitHub. As you can see here, this is my GitHub account. And as you can see here, you can also add another GitHub account. So if you haven't connected Visual Studio already with your GitHub account, this is the way to do it. you just go to account, then add an account. You get a pop-up where you enter your email or username and password, and then you're done. After that, you see the owner. Typically, that's just one option here. In my case, again, that's me. And then you can choose a repository name, typically the same name of the project or the solution. Of course, again, you can change that. And you can also enter a description. And the last thing, then you can decide if this thing is private or public. So public means with the URL, everybody can have a look at your code. And private means, I think you know that, only you can access this thing and also people you invite to collaborate. So I leave this private. And now I create and push, and now some things will happen. And as you can see here, we have 2 changes, and now everything is gone. So what happened now is, let me just go here and then view all commits. So we see a history. And now you see that Visual Studio did 2 things automatically. The first one is it created 2 files, a Git attributes file, not important for us, but the other thing is the git ignore file here. So let me just double click, and then you see what's actually in there. And this is what I was talking about earlier. Here's the debug folder, for instance, uppercase or lowercase. Then you've got the bin folder, the object folder, and so on. So lots of folders and files, preferences. If it's a general git ignore file, I have to mention that. Maybe you see it here if you are doing some stuff with Xamarin. Not sure, maybe if it's the same for Maui today. So these are files that will not get committed and pushed, or not tracked rather, when they are changed. Okay, so this for your information, and you also see the change. Now, why is that green here? The background is green. This just means that this file did not exist before, and everything that's green is new. You also see the plus sign here. This means that this stuff has been added. Okay, it's brand new, and it was committed to your repository. Hey there, just a quick reminder, if you're enjoying this preview, you're going to love the full Blazor and Clean Architecture Masterclass. There's a huge discount for the first 100 people using the coupon code in the video description below. It's the lowest price ever, so check it out before it's gone. Now let's go back, and then you see this stuff here, also already very interesting, and I will show you the same thing on GitHub. Our current branch is the master branch, all right? And you also see that there is a remote branch under remote's origin. Now this means that the same branch is also available on your remote repository. So we pushed everything is synced. And now when we change something here on our master branch, you can also see that down here on the bottom right, that this is our current branch, and we've got also remote branches, that when we change something, then it is done on the master branch. And we will see that, for instance, then we have a change here locally on the master branch, but not on the remote branch. And to synchronize both, we have to commit and push our changes. One more thing I wanted to mention again is the second commit that was done kind of automatically is add project files. So the message was automatically added, add project files, and with that all the files that are not ignored have been added to our repository. Now when I, for instance, just go to the weather page and say my title now for this page is Get the Weather, for instance, I save that, and then you see down here there's one change. I can double click and then again see what actually happened there. You see the red background here. This means something has been removed there, something has been changed here. And now here you see again a green background, and here highlighted get the, and then the space. This is what has been changed. And now when I would commit this, so I go to the git changes, enter my message, and then I can say commit all, or I can decide to first stage a single change. For instance, if we made a couple of changes in different files, then I could say that I want to stage this and then say just the staged changes should be committed. And we can also say that we already want to push them, or you decide to first only commit. This means it's only committed locally, so we have this history then available locally, but it's not synchronized with the remote branch. Only after pushing that stuff it is synchronized with the remote branch. So if I would commit this, and we will do that a couple of times of course throughout this program, then you will see that we have here a change, and then we can decide to push that as well. And then again, it's always the same cycle actually. And then again, we will see the commit here, see the branch, and so on. Now, regarding the branches, we can go here to create a new branch and say it is based on the master branch. We will do that later, so I don't want to go into too many details for now here in the beginning. And one thing as well, what I can also do is I can unstage that stuff and say I want to revert or undo this change here, hit yes, and then we have no changes anymore. So this is, I hope, everything about Git in Visual Studio. Now let's go to GitHub. So I refreshed my profile, and as you can see here, this is my brand new repository, Blazing block. It is telling me what the main programming, well, let's call it programming language is. It's funny that it tells me that it's CSS for now. Maybe the most couple of lines that GitHub found in this project is CSS. But anyways, I hope this will change later. And here you see another representation of it, all right? So you see here could be the README file. You can also go through all the files, which is really nice. I really love that view here, or that feature of GitHub. So I do not have to check out my project on the hard disk if I don't want to, or if I'm not able to. Maybe I'm on another machine or on my phone. There's also an app for GitHub, so I can check out the code wherever, whenever I want to. And I can also, when I go back, I can also go to commits here, and then see the same thing we just saw on or in Visual Studio. We see the two files that have been added, the attribute file and the git ignore file, and then add project files. And with that, we see all these files here, also with the green plus, that these files have been added. And you can also see the changes. And then when we commit a change now to any specific file, like for instance the weather file for our example, then you would also just see the line that has been changed and the text that has been changed as well. Okay, so this a quick introduction into creating your Git and GitHub repository and how it looks. And on the next lecture, let me show you how you can check out or clone. This is the right term actually, how you clone a repository so that you can work with that thing on your machine. So let's do that next. Now, cloning or checking out your code is actually pretty easy. As you can see here, we are at the state that is very, very late in our project here, in our Blazing block project, Blazing block applications. We've got a bunch of feature branches here, so lots of stuff has already been implemented. And here you can also see the commits, 86 in total so far. And here the latest one is updated to .NET 9, for instance. So lots and lots of stuff has already happened. Now to check out the code, you see this green button here. When you click there, you see you have a couple of options actually. You can clone it with HTTPS, SSH. You can see I'm not using this one because I don't have any public SSH key. And you can use the GitHub CLI. And another option would be the git bash or the terminal. And for that, this URL here makes sense because you can just copy this thing. And then when we open the terminal, then there, or the PowerShell or git bash, whatever you want to use, then you can go to the directory where you want to clone your repository. And then you just enter git clone and paste this URL of your GitHub repo. It is cloning everything, and then you've got all your files in that folder. Now, Another option is using GitHub Desktop. So this would be the Windows client, for instance, a desktop application for your repository or for your GitHub account rather, and then you can open this repo there and then specify where you want to download this thing. And additionally, and this is pretty much the option I use every time, open with Visual Studio. So it will be opened directly in Visual Studio, and you can then choose where you want to store this locally. And the last one would be downloading the zip file. So for instance, in the course curriculum, you will find the zip file of the code for this project. And this is exactly what I did here. I just downloaded the zip, and then you get everything you need in this zip file. You can extract it wherever you want, and then you've got your own version of this repository, and then create a new repository out of that. So whenever you have your repository ready, and for instance in my situation, I sometimes work on my desktop machine, sometimes I work on my laptop, and when I want to check out a new repository on the other machine, depends where I started this repository, then I choose the Open with Visual Studio option. But when I want to share something, then I usually use Download a zip file. So everything works, everything is great in my opinion. And now we can move on with the next lecture. All right, now welcome to the Introduction to Clean Architecture section. In here, we'll first discuss what clean architecture actually is, why you might want to use it, and then, of course, we are also implementing it with our Blazing block application. So first, the essence of clean architecture lies in its ability to provide a maintainable, flexible foundation for software development, ensuring that our applications are easy to adapt and evolve over time. So for smaller to medium-sized applications, it might be overkill, but since you're here to learn something and maybe want to be ready for building bigger applications, I think introducing a clean architecture, in particular with .NET 8 and the new Blazor, makes a lot of sense. So let's begin by understanding the different layers in clean architecture. I will go over them real quick and then dive a bit deeper into each layer afterwards by using our Blazing block example. So at its core, we have the domain layer, which is the heart of our application. It contains all our business rules and entities, and next is the application layer, responsible for orchestrating business logic and defining application-specific use cases. Then the infrastructure layer deals with external interfaces and data persistence, while the presentation layer, in our case using Blazor, is all about user interaction and UI. Each layer has a distinct responsibility, ensuring separation of concerns and easier maintainability. And for that, we have these beautiful pictures here. And as you can see on the left, in the core really is the domain. And then the next layer is the application layer. And on top of that, we've got the presentation and infrastructure layer. And let me just activate the cursor here. So here now you see again core, then application, then presentation and infrastructure. And all of these layers point inwards to the domain. This is important. This is also the way we will then add our references, meaning that the application project, which it is then in essence, references the domain, the presentation references the application, and same for the infrastructure. Or to be more precise, in our example, then the presentation will reference the infrastructure, and the infrastructure then goes the way to the application and the domain, because when the infrastructure references the application layer and the presentation, the infrastructure, then we also have everything ready or everything available regarding application and domain. Anyways, important factor is that everything points inwards and that not the domain here, the core, for instance, references the presentation layer for some strange reason. So this is not what we want. And here on the right side, another representation of all these layers. You see again, domain is at the bottom. So still this is our core. Then we've got the application layer on top of that, implementing most of the stuff, and on top of that then we've got the presentation and the infrastructure. And I can already tell you, of course, that within the infrastructure layer, we will use Entity Framework to access our database. And the presentation, again, is simply our Blazor frontend that will then use the infrastructure layer and the application layer. But regarding the details, of course, we will see everything while implementing our application. Now, with our Blazing blog, we aim to build a scalable, maintainable blogging platform. Again, as you already know, we will utilize .NET for backend development and Blazor for the frontend. This will serve as a practical example to illustrate how clean architecture principles can be implemented effectively. So now let's dive a bit deeper into the layers. Hopefully I won't overwhelm you right at the beginning, but let's still start first with the domain layer of our blog. So here we encapsulate all the essential business logic and domain entities like blog articles and comments, for instance. This layer is independent of the frameworks and the UI, the supported. Again, this is just the core, so it focuses purely on business needs. Next is then the application layer, and here we coordinate application logic and interact with the domain layer. For example, we implement CRUD operations for our blog articles in this layer. It acts as a bridge between the user interface and the domain logic. And to reveal a bit more already, we will implement services here as well as commands and queries regarding CQRS, but more about that later, of course. All right, moving on to the infrastructure layer. This thing supports the application by handling data persistence and external interfaces. It implements the interfaces defined in the application and/or domain layer. In our blog, this would include aspects like database access and API integrations. Just think of Entity Framework, for instance. Our presentation layer is where Blazor shines. It's all about building an intuitive and responsive user interface. This layer interacts with the application layer and is responsible for presenting data to the user and handling user inputs. We will see how Blazor can create an engaging user experience for our Blazing blog. Now, integrating these layers in our blog, we see a clear separation of concerns, which is crucial for maintainability and scalability. We will walk through several examples or use cases of different blog features like adding a new article, updating it, and so on, demonstrating how each layer contributes and interacts with others. So to conclude, clean architecture offers a structured, maintainable approach to software development. It's particularly well suited for applications like a blog or an e-commerce application, where scalability and maintainability are crucial. I encourage you to adopt these practices in your projects, and of course, I'm here to answer any questions you might have. All right, now that was a lot of theory. So now in this lecture, what I want to do is first create add two layers, which would be the domain layer and the application layer. And my idea behind that is that I will first show you already how to retrieve and display articles. It won't look very nice, but you will get the idea with that. How would you get the articles, display them already on or in our Blazor application in the browser? But for that, the minimum version that is necessary is a domain layer with our articles entity and then an application layer. And in that application layer, we together will only implement a service. And this already leads to the so-called service pattern I was already talking a little about. And we will simply return some mock data. All right, so no database yet. This is really the minimum version we need here to make this possible, and then later we will build up on that and then also introduce CQRS, and then of course go deeper into Blazor, the component model, and what all that is about. So anyways, the first thing we do is create a new project. No, the first thing I want to do is create another branch. Now, although of course we could just continue implementing here on the master branch. Again, you're here to learn something, so I suggest we already create a new branch. And for that, I click on the branch here on the bottom right. Then I go to new branch, and here now I call this feature, then slash, and then simply clean architecture. All right, so this is the new feature that we want to implement, a clean architecture here for our Blazing block. And now what we can do is we can right click the source folder and add a new project. And as I told you in the introduction, we've got the name Blazing block here. So for this new project, we choose the class library, hit next, and then we also call this thing first Blazing block. And since this will be our domain, we just call this domain. Then no server, no client, nothing like that, just Blazing block and then domain. We hit next. Also .NET 8 as target framework, of course, and we hit create. And with that, we have our domain layer. Now, what we can already do is also we delete this file because we really don't need it. And we also add another class library project. Hit next, and we call this one Blazing block and then application for our application layer. We hit create, and there it is. I can delete this thing, hit OK, and we're good to go. And now we can already add the references. You see the image of the clean architecture model. So the domain is really the core of our whole architecture. Application is also part of the core, but the application now references the domain project. So here we go to dependencies, right click, add a project reference, and then add the domain. Hit OK, and now we see that the domain project is referenced by the application. Domain has no project references here because it's really the core, and it should stay like that. And then comes our UI, and same thing here. Let me just close everything first. We go to dependencies, right click, add project reference, and then we select the application project. So now we have a similar architecture to the one we've seen in the introduction lecture of the clean architecture. This will change. We will also add the infrastructure layer, of course, then later also web UI client. And with that, then we can also change the references a little, because for instance, if I would have already added the infrastructure and then the infrastructure layer reference the application, then I could tell my presentation layer here, the web UI, to just reference the infrastructure. And with that, it automatically also references the application and then the domain. Similar here now we have the application referenced, and with that also the domain project. All right, it always works like that, so we do not have to reference the domain separately here. Just for this current state of our application, I reference them that way. So application to domain, domain to nothing, and server then to the application. Okay, so far minimum version. Now in the next lecture we will create the article entity, but before we do that, you see it here, we've got some changes in our application. So now we can see it live. We created new projects, and here we also see, which is not saved, so let's save that. We see, for instance, now in the project file we see a new project reference. Korean background. I think you get the idea by now. So this is the new stuff. And now we can give this thing a name or enter a message for this particular commit. For instance, edit the domain and application layers. And I could say commit all and push, or first, if I'm not sure, if I want to push that to my remote repository, I first just say commit all. And we're done. We have that history now. As you can see it here, there is one outgoing. This means that this is not synchronized with the remote repository. So when I now go to view all commits, see it here, we've got this feature folder. That's because of the slash I used in the branch name. And with that, you can organize your branches. Really like that. For instance, you can also add hotfix / bugfix / and so on. And with that, you see that this branch is not even available remotely. So this is just available locally for now. And when we push this thing, then we will also see this here in the remotes. Okay, so far the Git changes and the commits, and in the next lecture again, the article entity. So let's do that next. So back to the Solution Explorer, and now we open the domain projects. And now comes a debate you will find everywhere. How would you name your folders, or how would you structure even now this domain project? Because there are a couple of ways to do that, maybe two main ways. We could, for instance, right click, add a new folder and call this thing entities, and in there then we would add a new item, the new class called article. All right, so with that we would have our entity, then the article, available in this folder. Or we try another approach, we remove this folder and create another one, or we could have just renamed this folder, but so maybe it makes more sense, I don't know. We call this folder now articles. So we name it by the feature, all right? Because later maybe you want to add something like a comment as an entity, maybe also a review, I don't know, something else that is available in the blog. And instead of adding everything to the entities folder, we structure everything by its feature, and we can then do that throughout the whole application. For instance, later then in the application folder, in the application project, we will not create a folder called services, for instance. We will create also a folder called articles, and in there then we'll find an interface and an implementation class for that interface, the article service, for instance. Or regarding repositories, it's the same thing. So again, many ways to do that. Always up to you and your team, and I recommend just looking around in the internet and see, well, how are people doing this? Maybe you find other references on GitHub, of course, and then you will see you've got entities folders, you've got feature folders, and so on. Now, I would like to do it with feature folders, but you will see that in the end, it will be kind of a mix, because we will have generic files, generic classes, and in that case it makes sense to still use a folder or structure by the actual type. Okay, so you have again the debate between structuring by type or structuring by feature. In that case we're using feature. If we would use an entities folder, it would be the type. All right, but again, you will see, for instance, regarding exceptions, maybe that I will then create an exception folder. Long story short, what I want to tell you is, in the end, if you structure most of your application by the feature, you may save time looking for a certain implementation. Now, the next step is to right click and add a new item. And again, this is now our beautiful article. And I just create this thing, call this public, or give this the public access modifier. But the question actually is, I'm using the term entity here, but what actually is an entity? Well, in case of the article, this thing will later be stored in the database, and to be able to store this thing in the database, it would make sense to use also an ID. So for instance, when I now enter prop and hit tab, so I can add a property here, I use simply an integer for that ID. When we later then use Entity Framework will recognize that the ID field is the identifier field. So one unique identifier, one unique ID to know what article that is, what entity that is, and this is again the essence of entities. If you want to compare objects, you would also use the ID and then see that this is exactly the same thing. It's different with value objects, for instance, as the name implies. There it's getting down to the actual values. So just as a side note, regarding an entity, we need an ID. And we could go even further and create other classes, a base ID, for instance, that the article then inherits from. We will do that, but I want to do that later, because in the beginning I want to keep things as simple as possible. All right, so we've got our ID. Now the minimum other properties I want to add is a required string for the title. Then I also want to add another string which is nullable for the actual content of this article. Then we could actually add a date time for the date published. All right, and we can also say by default, let me close the Solution Explorer again. By default, this is date time now. And the last thing, which I think makes sense, is we add is published, and by default, let's set this to false. This is already the default value for Boolean value here, but let's just write it down here as well. So we've got our article entity in the articles folder because we're structuring everything by that feature. And that's already it for the domain for now. All right, so here we see this is an entity. It's the core, or in the core of our application. And now in our application layer, we will add something else to be able to use that article. And then in our presentation layer, we will use the application stuff here implemented to display the articles in our web application. So now let's commit this, and then I won't show you every single commit because I think this will get boring after a certain while. But I will do that. I will commit this, and then we will move on with the application layer already and implement a service first. Now, regarding a service, what should this thing do? Well, in this particular case, what I want to do is simply return some or just one mock article. I don't want to access a database yet. So what we will not implement is a so-called repository. More about that later, because a repository using the repository pattern would then use the database context to access a database table, then our articles table later, to retrieve all the articles that we want to see then in our web application. Again, to make things simple in the beginning, I just want to show you the very first steps, the minimum version here, where we just implement a service in the application layer, because this service, well, in essence, has the business logic. So it's not connected to any external service, which would be then a repository accessing a database, right? So this would then be some external stuff, and this then would be placed in the infrastructure layer, which comes later. For now, just mock data, only the application layer. So we add a new folder. Again, we could name this thing services, for instance, if you want to structure it by types, or we now say simply again articles. And then we add two items here actually. The first one is an interface for ArticleService. Public interface it is. And here now we add another item, which is the implementation class, the ArticleService. Let's also make this public. And now in the interface, we say that let's just implement one method to return the list, or a list of articles. So what we can do, for instance, simply return a list of article, and that's the using directive we need here, or the reference, and we call this now get all articles, like that. And now here we implement the ArticleService, and of course we have to implement the interface here, and we just create dummy articles. So we return a new list of, there it was already, of articles. And here now we say, for instance, one new article, which has the ID 1, title is my first article, content, this is my first article. And then maybe let's add another one. So we just copy this, put it down here like that. ID is now 2. Second, this is my second article. format this a little bit, at least try to. All right. So this is our service. I know it's really simple at first, but the next step now is to register this thing so it is available in the end in our web UI project. Now, if you're already a bit familiar with that, we could in essence go to the program CS now and then say here simply builder and then services at scoped service, for instance, and then the article service. And then here the implementation for that is also the article service. This is dependency injection in action. All right. We say whenever we want to use the article service, so whenever we inject an article service, we want to use this implementation class here. For instance, we could implement an article service or add an article service to, call it that way, and also say that this thing implements the article service, and then whenever we want to inject the article service, then we will use the implementation class article service too. Problem is with that approach now, we actually want to use a clean architecture here, right? So one thing to note is maybe separation of concerns. So what you would rather do instead of registering the services or whatever you want to use later, that will also be the data context here in the program CS of your client project or your presentation layer. What you want to do is you want to register the stuff here in the application layer. Now we have no program CS here, so how is that done? Well, for that we create another class, and typically we call that dependency injection because that's what it's all about, right? So let's do exactly that in the next lecture. All right, now I already told you here, typically you can register a service in the program CS of your web UI project. And now regarding clean architecture, since we want to, for instance, separate the concerns, we will do that in the application layer. And how would you do that? Well, you create a new class, and typically you can call this thing dependency injection like that. And in here now, this class will be a public static class, so you cannot instantiate this thing, so creating an object of this class. And in here now we add an extension method that extends the functionality of the iService collection, which is the .NET interface used for registering services in an application, right? So this is what you actually use here. You see there the iService collection, a collection of services for the application to compose. This is useful for adding user-provided or framework-provided services. And instead of using it here in the program CS of our Blazor project, we now do it here. So how's this done? Well, we implement a public static method returning the iService collection. We call this thing, or first add a reference here. And regarding the reference, this is the NuGet package, Microsoft extensions, dependency injection, abstractions. So we find and install the latest version, or you go the other way, right click the project, manage NuGet packages, and so on. So let's do it in this case that way. And now here, what we can do, we add this thing, add application, because we want to add the application layer with that. And then already suggested here, this iService collection services, and with the this keyword we indicate that this is an extension method. All right, okay, and now here we can simply now use our service collection services, similar to the thing I showed you in the program CS, and then here say add scoped article service, and in the end we return the services, and that's it. So here you see the complete code, static class dependency injection, and then public static iService collection add application with the iService collection services as an argument. With this keyword, it's an extension method. All right, extending the iService collection or the functionality of the iService collection. And then we register the ArticleService as a scoped service. Now, regarding the way we register this thing, scoped means that it's added with a scoped lifetime. So that in return means that a new instance of the service is created for each request in your application, or in other words, if two different parts of your application need the ArticleService during the same request, then they'll both get the same instance. Okay, and again, this here is the magic also of dependency injection. So as soon as an article service is requested, it should provide then an instance of the article service. And this is an implementation of the so-called interface segregation and dependency inversion principles of the solid principles, where your code depends on abstractions, in this case interfaces, rather than concrete implementations, right? We could also do something like that, but again, we use another principle here, and that's it already. All right, so with that, we make sure that concerns are separated. We encapsulate the dependency injection setup within this application layer or the application project. And well, in essence, we can enjoy all the other benefits of a clean architecture like modularity and reusability. Maintenance is easier and upgrading is easier because we only have to look at the this specific file here if something changes in the application layer. Testing and mocking is easier, and in the end also compliance with the dependency inversion principle, meaning by depending on these abstractions rather than a concrete implementation in the presentation layer in our case, again, we are adhering to the dependency inversion principle, again, also part of the solid principle. So in the end, it's more flexible and a more decoupled architecture, which is the essence of the clean architecture. And now we are almost done to be able to use this extension here. We now finally go to the program CS of our Blazor client. And here now we can say builder services at application, and I don't know why it is not suggesting the reference, but we can add it here. So blazing block application it is. And now we also know this function here. Perfect. So now we combined everything. And now the next step is to use the article on our client to finally display the articles. So let's do that next. All right, so we are here now already in our Blazor project, and we see the components folder. We already talked about that, layouts and pages. Now again, we have two options here in essence. We could add another page called articles, for instance, or we create a feature folder where we then have all the articles related stuff in an articles folder. Now I want to go through the details and more deeply into Blazor later. So for now, let's just keep things simple, or I hope as simple as possible, by adding a new Razor component here in the pages folder. And I will call this thing now simply articles. And with that, you see we've got a new component. And to make this thing a page, we add the page directive here and add the route articles. That's it. All right. Now to make this thing accessible, well, of course, we can just enter the articles route, or we go to the nav menu here, maybe copy this at first. And now the href is articles. We can also call this articles. Now this thing is for the icon. If you want to use something specific, there's a little trick. We can Google for bootstrap icons here and then go to the first hit. And here, for instance, nope, articles not the one. Let's search for document, for instance, and then maybe something like that. And here we can copy the SVG, close this again, paste it here. And now we have the icon in front of the articles text. All right, now back to the page. Here, this thing will be kind of similar to the weather forecast page, because what I want to do is I want to use the onInitialized method to, well, get the articles. And we expect a list of articles. So let's also add this as well. So here in the code block, we have a list of articles and add this reference. And as you now know, this can be moved to the imports eraser. So now we have the reference to domain articles for our article class. We call this articles, and this is simply a new list of articles, for instance. And now here, protected, override, and then on initialized. Doesn't have to be asynchronous in this specific case. So what we can do here now is we inject now the article service and then use the GetArticles method to get the articles. So to do that, we add @inject and then article service. Again, another reference is necessary here. So let's move that to the imports as well. Available, let's call this article service. And here now we say our articles, or first maybe var result is the article service get all articles. And if the result is not null, we say that our articles is now the result. Okay, so far the easiest way to get the articles. Now, how would we display them? Well, first, for presentation purposes, we can check if the articles count is 0 at first. I know might be the case that we do not have any articles, so we would see this thing here forever, the loading text. But for this first example, this is totally sufficient in my opinion. So what we can do now is, as soon as we have some articles, we display them with the help of a for each. So for each article in our articles list, we say, show me the article title first, then the article content. Maybe here we just make an H4 out of that. And of course, we can also add the article date published. All right, I would say that's it already. Let's try that. So we run our application. There we are. We can go to articles, and that was fast, right? We see the title, articles, my first article, the content and the published date, and then the second article with the content and the published date as well. One tiny thing we can add is the title. So let's just copy that, paste it here, and make this the page title. And another thing which I already told you, but still want to tell you again, if we also simulate this delay, which could be there. So now we have a task async, and we use the oninitialized async method. If you do it like that, then it would make sense to also add stream rendering, right? Because when we now restart the application, there we are, it is restarting. Title is different now, but we can go to weather and then back to the articles. Takes a second, and then we see the articles. But if we now again add attribute and then stream rendering, save that, we can enjoy exactly that, the streamed rendering. So here back to articles, we see the loading text, and then we load the articles. So with that, this is the very first step, let's say, into clean architecture. We have the complete way from our presentation layer down to the application and the domain, which is the article, and then we go back to the service in our application layer, and then to the presentation layer, where we can make use of the article service thanks to dependency injection again, and of course also use the domain, the article here in our application. So this was hopefully the most simple way for the first steps into clean architecture. And the next steps now are to use an actual database and not use these mock articles here. So for that, we will then add the infrastructure layer. So we've got everything available then, apart from the client maybe, so the web UI client, but this comes later, of course. So we've got the presentation, domain, application, and then the infrastructure together with the database. And after that, then we will move from the service pattern here, meaning using a service like this one, to CQRS. All right, I hope you're ready for that. So I see you in the next section. All right, now before we start implementing, we have to clarify what Entity Framework actually is. Now, Entity Framework is a popular ORM or Object Relational Mapping framework. It is developed by Microsoft for the .NET framework. It enables developers to work with data in a more object-oriented way, abstracting the underlying database system. Now, you might ask, what's an ORM? Well, in general, an ORM, or again, Object Relational Mapping, is a programming technique used to convert data between incompatible systems, specifically between object-oriented programming languages and relational databases. So in simple terms, an ORM allows developers to work with databases using objects and classes instead of writing raw SQL queries or dealing with low-level database details. Now, the benefits by using Entity Framework are you can interact with the database using C# and LINQ, standing for a Language Integrated Query, instead of writing SQL queries directly. And additionally, with the help of Entity Framework, we will also use code-first migrations. And now code-first migrations is a feature that allows developers to manage database table changes using code instead of directly modifying the database tables or schemas or whatever. Now, it provides a systematic way to update the database to keep it in sync with your application's data model while preserving existing data. Now, when using code-first migrations, in general, you'll start by defining your data model using C# classes, like the article entity, for instance. Entity Framework will generate the corresponding database tables based on these classes. So, in essence, we will see a representation of our article entity as a table in the database. As your application evolves and you make changes to the data model, code-first migrations will help you apply these changes to the database. And that's pretty much it. So let's start implementing everything in the next lecture. Of course, we are still using our Blazing blog application. For the database, we will use the free edition of SQL Server. To be more precise, it's SQL Server Express. And in the very next steps, we will first create a new branch, then install necessary NuGet packages, and with that also the EF Core tools. Now, before we start with the actual implementations for the infrastructure layer, first, as you can see here, still we're on the clean architecture feature branch. And when we have a look here at view all commits, we see that we still have 5 outgoing commits. This means that this stuff is not pushed to our remote repository. So let's do that first. We can simply go here, for instance, and then select push. And as you can see here, pushing feature clean architecture started. And now we should see the branch here as well. And now what I also want to do is I want to merge the clean architecture branch to the master branch, because this is actually just the clean architecture introduction branch. And then we create another branch for the infrastructure layer. So now how can we merge that so that the master branch has now the same state as the clean architecture branch? As you can see here, master is still at the state of add project files, and clean architecture is here at display articles with Blazor. So now when we right click the master branch, for instance, we see merge master into feature clean architecture. Actually, we want it the other way around. So what we do now is we right click the master branch again and say checkout. And now again, you see this is the current state of the master branch. We can right click the clean architecture branch, merge feature clean architecture into master. And you see this merge will change 12 files, and we can automatically commit the changes after the merge if there are no conflicts. And it would tell us, or Visual Studio would tell us if there are already conflicts, but there aren't any. Conflicts are in general when, for instance, two developers worked on the same file, maybe even on the same lines, then and then Visual Studio or Git, in essence, would not know, well, which change is the right one, what is the truth, and in that case, you would have to manually decide what you want to use for your final merge. But in our case, everything's fine, so we can merge that, and again, now we can say sync or push. Let's sync this. This means that we first pull everything from the remote repository, so if there are any changes, then we would get the latest state, and now, as you can see here, everything is at the same state. Great. And now we can create a new branch, again based on the master branch, and I would like to call this feature and then infrastructure dash layer, for instance. All right, let's do that. Now we have the new branch locally again, not pushed for now, and the next step now is to actually make our implementations, meaning adding the infrastructure project and then add entity framework and all that database boilerplate stuff. So I see you in the next lecture. All right, so now first add another project, and with that then we have all our layers. Again, apart from the client project for the presentation layer. So right click the source folder and we add a new project, again a class library. We hit next, and now this name is Blazing Block Infrastructure, like that. We hit next and we choose .NET 8 for our target framework. We hit create. Again, we can remove this example class here. So let's delete this thing. And now again, the references. Well, again, when we have a look at the image, again, we see application to domain and actually presentation to application, also infrastructure to application, and the presentation layer also to the infrastructure, right? So we need a reference in our presentation layer to the infrastructure layer. Now here we already have the application project. So actually what we can do is we can remove this and then add another project reference to infrastructure. We could also just leave the application there, then add the infrastructure, and in the infrastructure now we add another project reference to the application, like that. And then you see with that we have application and domain in the infrastructure layer. And now here in our presentation, again, we have the infrastructure and also the application and also the domain with these references. Okay, so now when this is done, what we can do in the next step is already add entity framework as our object relational mapper that we will use to access a SQL Server database. So let's do that next. All right, now when this is done, what we can already do is create our database context that we can use to access our, well, data from the database. So at the root of the infrastructure project, we just add a new item. And now what I like to do is I usually call that, for instance, just data context. But if you like, in a more professional environment, maybe you can also give this default name, ApplicationDbContext, so you know that this is the database context of your application. Later, for instance, when you want to separate your application database from a user database, then you will see this totally makes sense. In that case, then you would have an application database context and also, for instance, a user database context. So let's just create that thing. We make this public again. And here now we can already say that we want to inherit from DB-Context. Of course, we don't know what this is, but with control and period, you already see the suggestions. For instance, we want to install the package Microsoft Entity Framework Core. That's exactly what we need. So let's just hit find and install latest version. And with that, we are done. So now the next step is to add a constructor. This is what you need with Entity Framework. So we say CTOR, hit tab. This is our ApplicationDbContext now. And now we need an argument which is of type DbContext options. We call this options. And now we also use the base constructor with the same options. Now the next step is to give this thing a database set as a property. So hit prop and then tab for the property here. Type is a DB set, and then what we actually want is a database set of our article entity, and we give this usually the name articles, meaning we just pluralize the name of this entity, and that whole thing now in essence is the table in our database that will represent all our articles. And with that, we already have our database context, but of course we are not done. Hey there, just a quick reminder, if you're enjoying this preview, you're going to love the full Blazor and Clean Architecture Masterclass. There's a huge discount for the first 100 people using the coupon code in the video description below. It's the lowest price ever, so check it out before it's gone. The next step is now to add a connection string to our SQL Server database, because this is what we want to use. Then this connection string has to be used upon registration of the database context. And for that, we also need the SQL Server provider and configure everything then again with the iService collection, so that Entity Framework knows to use SQL Server with this particular connection string that we want to grab from the app settings JSON file. So when we have a look again, you see that the app settings JSON file is actually here in the presentation layer. We're currently in the infrastructure layer. So how do we combine all that? Well, let's do that in the next lecture. Now, before we continue with the actual connection string and the SQL Server provider and then wiring everything up with dependency injection again, I started Googling a little bit again, and this time for SQL Server Express, because this is the database I am going to use in this course. It is, as you can see here, a free edition of SQL Server. So if you just Google for SQL Server Express, you should find the first hit here and then scroll a bit further down, and there you find SQL Server 2022 Express, also the developer version. Everything available for free, so I recommend just download that thing and install that. And afterwards, if you want, you can also use the SQL Server Management Studio. So you can again just Google for that thing and click on the first hit, and then here is the download link. I just think this is a great tool to manage your SQL Server Express databases. So you can run SQL queries there, you can have a look at the database with its tables and so on. So these are just my 2 cents. Of course, there are a bunch of management tools. Let's say you can even just use Visual Studio if you want, but I think this is a great combination. Visual Studio with SQL Server Express, and then also the SQL Server Management Studio. All right, now that said, let's add the connection string. I can close this actually. And now again, you see the connection string is here in our presentation layer. Now, how's this done? Well, typically you would add another section here, and you already see the suggestion connection strings. And by default, this is also called default connection. And when you're using your SQL Server Express installation locally, it looks as the following. And again, I mentioned it already, when you deploy your application to Azure and want to use an Azure database, then you can configure it in a way that it also looks for a default connection, but then grabs the connection string from your Azure configuration. All right, that said, the connection string now starts with server, and then you can write localhost and then SQL Express. Then comes the database name with database equals, well, we can say blazing block DB, for instance. Then we say trusted underscore connection is true. And also since .NET 7, we have to enter trust server certificate also true. So this is the complete connection string. Server equals localhost / / SQL Express. Then the database name, in our case, maybe blazing block DB. Then trusted connection is true, and also trust server certificate set to true as well. And then the next step, the SQL server provider for entity framework. So here in our ApplicationDbContext, we have entity framework in essence already wired up with the database set for the articles, but now we have to tell our application that we want to use SQL Server. Now, how's that done? Well, again, back to the infrastructure layer, we add another NuGet package, and here, make sure to select browse and not installed. You can, for instance, just search for SQL Server, and you should get, as a result, Microsoft Entity Framework Core SQL Server. As it says it here, Microsoft SQL Server database provider for Entity Framework Core is exactly what we need. So just install this thing. We accept, and that's done. Now in our dependencies, we see Entity Framework Core and SQL Server. And now how do we register that? Well, it's similar to the application layer. Here in the presentation, again, we see we use the add application method from the application layer here, or this extension method in essence. Now we do something similar, but we need access to our connection string. So how is that done? Well, let's have a look at that in the next lecture. So again, in the application layer, we have the dependency injection class with this extension method here, iServiceCollection add application. Now again, we create in our infrastructure a new item, call this dependency injection. Again, this is a public static class, and in essence, we can just grab this thing here, paste it there. Now we don't want to register an article here, and the name should also be different. So what we can do is add infrastructure, for instance. And now we already have the service collection here as a parameter. But since we need access to our app settings JSON file, we have to add one more parameter, and this is the iConfiguration. All right, because usually when you have a smaller project and when you go to your program CS, you can access this app settings JSON file, the configurations with builder and then configuration. And as you can see, hopefully, yep, now this is the web application builder configuration, a collection of configuration providers for the application to compose. This is useful for adding new configuration sources and providers. Now you know, right? But here you can, for instance, call the method getConnectionString. As you can see, it's shorthand for getSection connection strings. And then here you can add default connection, and that's how you get the connection string. But we are using a clean architecture here, so this is not an option. What we want to do is, let me just put this into a new line here. We want to add the iConfiguration here as well. So we just say iConfiguration, call this configuration, and it already gets that this is from Microsoft Extensions Configuration. iConfiguration represents a set of key value application configuration properties. So this explanation, I think, is a bit better when we have a look at the app settings JSONs, because this is exactly what this is. We have sections with a key and also a value. So with that, now we can register the database context and tell it to use SQL Server as a provider. So again, we start with services and then say add DB-Context, and in our case, it's the ApplicationDbContext, that's the one. And now this thing gets options. So here we say options, and then we say options use SQL Server. This comes from the SQL Server Provider package. And here now this thing wants a connection string. And now instead of builder configuration, as we could use it in the program CS of the presentation layer, we say configuration get connection string. And this is now exactly the same thing. Default connection like that. And we add some parentheses and we are done. So now the DB context is registered with the SQL Server provider. And the last step, of course, is to also use this method here. We just say builder services and then add infrastructure. And this time we have to give this thing the configuration. So builder configuration it is. And does it know the method? No, it doesn't. So let's just add the using directive with the reference by ourselves. Infrastructure it is, errors gone, and we're done. Now this thing is wired up. Now, as you can see, I already stopped the application because the next step now actually is to build or create our database with the articles table. And for that, we are going to use code first migrations. But before we do that, I wanna make a little change in our domain, because this here, I don't really like that, because the ID is something that several upcoming entities also need, and maybe we can add some other properties to these entities as well. So maybe we can make use of an abstract entity class here. So let's do that next. So currently we only have the article class with the ID here. We have other properties as well, but two properties I'm missing here is something that I like to see in a database for pretty much every entity, and this is a date of the creation of that entity and maybe also a date for updating. We could also think of a soft delete feature, meaning that we just add a flag if this article now is deleted or not, instead of really deleting the entry from the database. And for that, we could also add another date for, well, date deleted, for instance. But for now, let's just say this article is not soft deletable. We can switch the publish state, so maybe this already makes sense and is enough. But regarding the ID, this is definitely something we can move to an abstract class. So what we can do now here in the domain is we add another folder and call this now abstractions. Now in here we add a new item and call this thing now simply entity. And here now we say this is a public abstract class. So when we now inherit from this thing, we get the properties that we define here. And the first thing is, again, the ID. And as I now already told you, I also like a date time for date created, which is simply by default date time now. And then I also want another property, date time date updated, which actually can be nullable because, well, maybe we just create an article and it hasn't been updated yet. So that's that. And now we go to the article class and say here that this inherits from the entity. And then we should see a little warning here, because article ID hides inherited member entity ID. Use the new keyword if hiding was intended, but it's not intended. So let's just remove that thing. And with that, then later when we, for instance, add a comment as the next entity to our blog, we can also inherit from the entity, and then we do not have to add the ID and the other dates manually again. So a little bit of inheritance here Quite neat, I think. And now in the next step, we can finally make use of code first migrations. So let's do exactly that next. All right, so we've got our article and entity classes. Dependency injection is done. Everything is registered. So now code first migration. For that, we need one more package. So let's just right click the infrastructure project, manage NuGet packages, and this time I just enter tools. And with that, we should get this one, Microsoft Entity Framework Core Tools. These are the tools for the NuGet Package Manager console in Visual Studio. Another alternative is simply using the CLI, meaning, to be more precise, the .NET Entity Framework Tools. This is something I used in the time tracking course, but maybe the tools are easier to use. I leave that up to you. In this course now, I just want to use the tools because I see it more often. So maybe it's the easier way. Don't know if it's the better way, but it's definitely also pretty simple. And as you can see here, when we install this thing, we get the following commands. Add migration is one command we will definitely use, and the other one is update database. All right, so please install that thing in the infrastructure project. And now let's just try to run the code first migrations. Make sure that the application is not running, so close the terminal and then open up the package manager console. Now here, regarding the project, I select the infrastructure, and then we can call add-migration. When you hit tab, you see that this is also suggested then. And let's just call that initial for the initial migration. All right, we hit return, and then let's see. Build started, build succeeded, and we get a warning. All right, so here you see what the warning, or the error actually already says, that the startup project web UI server, and this will be the same, this will stay the same even when we add the client project, it doesn't reference Microsoft Entity Framework Core Design. What the hell is that? Where does that come from? This package is required for the Entity Framework Core tools to work. Ensure your startup project is correct, install the package and try again. So when we have a look at the dependencies again, we see that the tools are here. And when we open that up, we also see that there is this design package. And this, it seems, is also necessary for our server, meaning the web UI server project. Well, let's just add it then. So again, dependencies, manage NuGet packages. Again, we go to browse, and we can actually again install the tools package. Hit install here. We of course accept everything. And now we close this maybe. And let's just try that one more time. Add migration initial, build started, build succeeded. And this result is now different, right? To undo this action, use remove migration. So you already see if you did something wrong, maybe you did not add the entity class and you wanted to add it, but you already run the command here, add migration initial, then you can remove the migration before you update the database. When you already updated the database, that's another story. Then you would have to modify some stuff in the database, but for now, we can see that a migration file has been created and already opened for us. And when we have a look at the Solution Explorer, we also see that this migrations folder now is in the infrastructure project, okay? And this just means database has not been created yet. This is just the migration file, and this migration file provides two methods, an up method and also a down method. Well, the down method is simple. This just means when you roll back this migration, it will drop the articles table. But when you now apply that migration, then the up method will be run. And as you can see here, it will use the create table method to create our articles table. This is exactly the same thing, or exactly the same name that we used here for our database set, right? I told you articles is then the name of the table that will represent our articles in the database. So that's correct. Then we have the properties. We already see the ID here. So this comes from our base entity. Then we have the title, content, date published, is published, and then again from our entity our base entity class, the date created and updated. And as you can see, the date created is not nullable, but date updated is. And one more thing here, it already knows that the ID is an identity field and it will auto increment that thing. And it set the ID here as the primary key. Perfect. It's exactly what we want. So now we can go back to the package manager console and run the command update-database. We hit return and then wait for a couple of seconds, and then we will also see the commands that will be executed for our database. As you can see it here already, create database, blazing block db, and some other stuff as well. And in the end, you will see that it creates the table articles. There it is, create table articles with the ID and so on. All right, this is done. And now we can open up SQL Server Management Studio. There it is. I already connected to my local server, and when we open databases, we see our blazing block database. Open that up, we see tables. Now we have this EF migrations history table. Now this is something that is actually only interesting for Entity Framework itself, so we do not really have to have a look at that thing, but the articles table, this is something that we want. As you can see, we have all our columns here, and when we right click and for instance say select top 1000 rows, we see the select statement, the SQL statement. Of course there's nothing there, but when we now select edit top 200 rows, then we can actually add an article. Again, my first DB article now, for instance, this is my first article. Date published now is 2023, December 20 is published. Yes, it is. And date created, same thing, 2023, December 20. So now we have that thing. ID is 2 because I had a little error here. As you've just seen, I hit return before I added the date published. And that's why SQL Server thought, well, in that case, since there was an error, I have to increment the ID already. But if I now say my second DB article, for instance, this is, well, again, let's just say my second article, date is now maybe in the future. We say true as well, and at the proper date, now we see ID is 3. So it's really incrementing the ID properly. All right, so we've got 2 articles here already. And on the next step is to, well, get these articles, retrieve them from the database. So no mock articles anymore. And for that, we will make use of the repository pattern and implement an article repository next. Now again, my idea here is to keep things as simple as possible in the beginning, and later then we will build up on that. So what I want to do now is I want to create a specific article repository. We could already implement a generic repository, but since we just have articles so far, let's make things again easy and simple, but just creating an article repository. This is also part of the domain. So here in the articles folder, we can add the interface for that. So we add a new item and call this article repository. We hit add, again, make this public. And here now, again, similar to the service, I just want to add one single method. So we add task list article, and then here get all articles async, like that. So this is now the interface, and regarding the implementation, this goes to the infrastructure because this is where we need that and where we access the database with the help of Entity Framework. So here now, I told you sometimes you mix the folders. So this time I'm not going to add an articles folder. Here I will create a repositories folder because we can then group all the repositories. And when you write this properly, repositories, then this looks better, I guess. So here now we add again a new item, call this article repository, like that. And this public class now implements the article repository. Reference has been added. We implement the interface, and there is the method. And now the implementation looks like that. We need access to the database, and this is why we need access to the database context. And to have the database context available, well, we make use of dependency injection. So what we can do is we have a private read-only database context here. So ApplicationDbContext, name is now _context, like that. And now with control and period, we can say generate constructor article repository with ApplicationDbContext context, and it's automatically set. Perfect. So with that, then we have the ApplicationDbContext available. And now regarding the method, we can simply say return and then await. Please note that the async keyword has been added automatically, and IntelliCode already suggests the correct code. It's context articles. So again, here maybe you see period, and then we have the articles available. So this is our articles table. And then the last method here, to list async. And with that, we have all our articles available in the infrastructure layer. And now we make use of this repository in our article service. So let's do that next. So now we go back to our article service that we find here in the application project. And now instead of these mock articles here, we say again, we want to inject something here. And in this case, it's the article repository. So private read-only article repository. We can call this article repository. Again, we create the constructor. There it is. And now here we just return article repository get all articles async. But this is an asynchronous method, so maybe let's change that a little bit. Here we also return a task with a list of articles, and maybe we can also call this now get all articles async. And now here, same thing, we return async task list articles and call this get all articles async. And now this should, when we also add the await keyword, this should look way better, no errors anymore. We save everything, double check in the interface here, task list article, get all articles, and here in the implementation now the service. So we have the steps from the service to the repository. Everything should be wired up with dependency injection, right? Let's double check to be really sure. So here now in the application project and the application layer, we have our article service. Then let's have a look at the infrastructure. Maybe we forgot something, right? So here now we see DbContext is registered, but what about the repository? So now here, real quick, we can say services, also add scoped, and then article repository. And for that, we want the implementation in our infrastructure layer here, the article repository. So let's save that. And then let's have a look at the client here in our articles page. And here we see that we changed the method. It's now an asynchronous one. So await article service, get all articles async. And now hopefully we did not forget something. Let's just run that. And here we are. And it is loading the database articles. And now app is still running. Let's, for instance, add a third one, my third article, third one. Again, date is now maybe the 22nd, also published, same date here. Great, we hit return, ID is 4. And now when I just refresh the page, we get 3 articles. Perfect. So everything is wired up now. We have, again, when we have a look at the Solution Explorer, we have the presentation layer here with our Blazor static server-side rendering project so far. The infrastructure is there with Entity Framework Core or Entity Framework 8 and the SQL Server database. We have the domain and the application layers, but here we are still using the service, and that's something that you rarely see. I already told you that what you more often see when using clean architecture is CQRS with the Mediator pattern. And this is what I want to talk about in the next section, and of course also implement that stuff. So now I will again commit this, merge the branches, and then in the next section we create another branch for CQRS and then add all the implementations necessary to use queries, the so-called queries first, to retrieve all the articles, and after that then we are going to implement all CRUD operations with CQRS, and then of course continue adding more and more features. So I'm looking forward to seeing you in the next section. Welcome to the introduction to CQRS and the Mediator pattern section. Now first, CQRS stands for Command Query Responsibility Segregation and is a design pattern where the operations of reading data, the queries, and also modifying data, the commands, are separated. This separation can help manage complexity and optimize performance in software systems. In the context of our Blazing blog, this means regarding the commands, these are operations like creating a new article, editing an existing article, or deleting an article. So this means these commands change the state of the system. On the other hand, when we have a look at the queries, these are operations like viewing the list of articles or reading a specific article. So these queries only read data and do not change the state. So by using CQRS, you can independently optimize an application for both read and write operations. For example, you might use different models for reading and writing data for more efficient queries or to handle complex domain logic in commands. Now, the Mediator pattern is often used together with CQRS. It reduces coupling between components in a system by allowing them to communicate indirectly through a mediator object. It's like having a central controller that handles how different parts of an application interact with each other. For instance, without Mediator, components like the UI for creating or editing articles, the logic to save data to the database, and the logic to retrieve articles might be tightly coupled. For that, I have this little picture here. You can see, let me just activate the cursor here. You can see these are the UI components, for instance, right? Blazor components, and these then would have, let's just assume you're still on the server, they would have to call a certain service. For instance, the article service to create an article or to read an article, stuff like that. So here these little arrows in between mean that all these are requests for services. Or if we would use Blazor WebAssembly, for instance, now I'm a bit more in the future, but here then we would use a web API. So we would call a controller first, which is still the presentation layer. All right, so a web API is still presentation, not only the UI. Web API is still presentation layer, and this thing then, with the help of a controller, would also call a service, right? So we would make use of services then with requests. These services then will, for instance, inject a repository, and this repository then will have access to a database and get the data, change data, whatever it is, and then everything, of course, goes back to the UI in the end. So this is pretty much the picture of building or using the service pattern and building the application without the Mediator pattern and also without CQRS. Now, compare it here with the mediator, this means you have a mediator class that acts as a middleman. The UI sends a command to the mediator, like create article, and the mediator decides what logic to execute. Similarly, when data needs to be fetched, the UI asks the mediator, which then invokes the appropriate query logic. Again, little picture for you here. On the left, again, we have the UI components, and as you can see now, we can use a command or a query, not simple requests, let's say. We have commands and queries that we only send to the mediator. No service, nothing like that in between. We just have a mediator object here. And this thing then uses a so-called command handler or a query handler, depending on what you send to the mediator, right? With a query, you need a query handler. With a command handler. And then the whole logic in the end is in the command handler or the query handler. So here then we might have other services or repositories, whatever it is. And these things then have access to the database to get the data, change data, whatever, and then send everything back to the UI. So again, when we have a quick look here, it's without the mediator. We have the services directly coupled to the UI components, but with the mediator, then we only have one mediator object. And of course, this could be way bigger. Right here, I just added 3 services and 2 UI components, but here we could also have 5 UI components, and all of them use the mediator with specific commands and queries, and then the mediator knows what to do. So the UI has no idea what will happen with my command or with my query. Just, dear mediator, give me whatever I want, and the command handlers and query handlers do the rest then. So again, I hope you get the idea, and later, of course, we implement everything. So I hope everything makes sense. Anyways, in a .NET and Blazor context, you can implement CQRS and the Mediator pattern using libraries like Mediator. Mediator allows you to send commands and queries through a single mediator interface, helping you to cleanly separate concerns. For instance, you would define commands and queries related to the article entity and handle them in different classes. The Blazor components would interact with these operations through, again, the mediator, making your code more modular and easier to manage. Remember the picture. Now, choosing CQRS with clean architecture over the traditional service pattern for a project like a Blazor-based application comes down to several factors: complexity, scalability, separation of concerns, and the nature of the application itself. So let's explore these real quick, and then we see CQRS versus service pattern, what might make more sense for your projects. Now first, complexity and scalability. Regarding the service pattern, in a typical service pattern, a single service layer handles both commands, write operations, and queries, read operations, and this can be straightforward for smaller applications, but can become complex and less efficient as the application grows. Now, CQRS with clean architecture, on the other hand, separates read and write operations. This separation allows each part to be scaled, optimized, and maintained independently. For complex applications or those with significantly different read and write requirements, this can offer significant advantages in terms of performance and scalability. Now, separation of concerns, CQRS provides a clear separation between the read side, queries, and the write side, the commands. The separation aligns well with the principles of clean architecture, where the goal is to decouple the different aspects of the application for easier maintenance, testing, and evolution of the system. Now, clean architecture encourages the separation of concerns at a higher level, structuring the application into layers with distinct responsibilities. And combining this with CQRS means you can have a very clean separation of the logic that handles writes from the logic that handles reads. Now, regarding the service pattern, we have no separation and tight coupling. All right, next is the application nature. Now, if your application requires complex business logic, different scalability needs between reads and writes, or if you anticipate it's evolving significantly over time, CQRS with clean architecture can provide the flexibility and maintainability you need. That said, for simpler applications, the overhead of implementing CQRS in clean architecture might not be justified, and the traditional service pattern might be sufficient. So in summary, the choice depends on the specific needs of your application. If you aim for a scalable modern architecture and complex applications, CQRS with clean architecture is a great choice. For simpler applications though, the service pattern might be more appropriate. And again, I told you that already. You can, of course, regarding our blog, build a simpler blog, and in that case then service pattern is totally sufficient. You do not have to use clean architecture. I really have to emphasize this, don't get me wrong. In many cases, in particular for smaller to medium-sized applications, you do not need clean architecture and CQRS. Still though, it does make sense because maybe you don't know how your application grows. So maybe it makes sense to start with clean architecture and also CQRS in the beginning, and then you are safe if your application grows. Anyway, with that, enough with the theory, I'd say. Now I think it's time to implement all that. So let's do that next. All right, now first things first, as promised, we create another feature branch. So we are currently on the master branch. We create a new one, also again called feature, and then let's call the CQRS maybe, or CQRS introduction. That's totally up to you, of course, but in my case, I just call it CQRS because this is the main point I want to show you here in this section. So let's create this thing. And then the next step, again, already told you that we need the Mediator, and for that we use the Mediator package, and this is done in the application layer. We already have the service here, and now we want to, well, remove the service in the end. So just change this implementation using the service pattern, and instead of that, now using CQRS. All the implementations for that happen here again in the application layer. So right click that thing, manage NuGet packages, and then in the browse tab you will already see Mediator is what I am looking for. Just pay attention there, right? There's no O here, it's just mediate and then directly the R, and there you see the package by Jimmy Bogart, 168 million downloads. That's just crazy. So you see how famous this thing is and how often people use it in their projects. So when this is installed, then we also have to register it or add it to our service collection. Again, we have our dependency injection class here in our application project. We want to make use of that in our starting project. In this case, still the web UI server project. So here now, what we have to do is we just write services, and now we have this new function add Mediator, but this alone would not work. We have to give Mediator our assembly. So how can we do that? Well, we use a lambda expression configuration, and then here I just open that up because maybe you want to configure more than just telling the Mediator package that we need, or we're going to use our current assembly. Anyways, here now we say configuration and then register services from assembly. That's the method. See there, register various handlers from one assembly. In our case, we can use type of, and then our class dependency injection, and from that the assembly, and add a semicolon. So again, iService collection add application. This method here we say services add Mediator configuration, and in there then we say configuration register services from assembly, and we use our dependency injection class, and from that the assembly. And with that, everything is ready to make use of Mediator. So let's implement a query next to actually replace the article service. All right, we are still in our application project, and now to create the query and then also a query handler, we can, well, do that or create the classes directly here in the articles folder, or we create another folder for this specific use case, which would be to get all articles. So here I create a new folder and then call this simply get articles. All right, that's it. And in here now, we just add two new items, two classes. The first one would be get articles query, and for that then the corresponding handler. So get articles query handler. And now the pattern or the steps you will see here are pretty much the same every single time you create a query. So here in the get articles query, first thing we want to do is we want to implement the iRequest interface of Mediator. So here now iRequest, see it here, a marker interface to represent a request with a void response in this case, but we want to return a list of articles. So here you see a marker interface to represent a request with a response. So here now in the angle brackets, we add the list of article. This is what we want. And with control period, we add the reference, hopefully. Yes, so this works. And that's it. This is our query. So we have a class, no body here actually, so might make sense to later when we refactor our project to use a record, for instance. But for that now, I really don't want to overwhelm you. So here we just we implement the iRequest interface. One more hint already, you see it is still just in quotation marks, a request. I told you in the introduction lecture about CQRS and the Mediator pattern that we're going to use commands and queries, but when you use Mediator here in that case, the actual object is still called a request. All right, so please don't confuse that with the service pattern maybe. In the end, it's still a request. We are requesting something, right? And we get a response back. But in the context of a CQRS, we are saying when we just want to read something, just view some data, it is a query. So we use the name query here. For instance, get all articles query. And in regard to changing something, updating, creating, or deleting something, then it would be a command. For instance, an create article command, something like that. All right. But here now for this little introduction, first, it's just viewing all articles. All right. I hope this is clear now. So we have the get articles query, and then we make use of this query in our get articles query handler. And here, similar thing, we implement the iRequest handler interface, also with the type now. But here, what we have to define is, you see it here, we can add, or we have to add the actual request first so that we connect both, right? So we have the get articles query, and in here now we enter the get articles query as well. So get articles query handler and then get articles query. So Mediator in the end knows, all right, whenever I see the get articles query, this thing here, I have to use the get articles query handler. But the problem here now is that we also added a response to the actual query, and we have to add the same thing here as well. So now with comma, and then we add the same return type that we already added in our query. All right, so now the error here is gone, but here we have to now implement a method. As you can see here, it says get articles query handler does not implement interface member iRequest handler, get articles query list article handle. So this is a method now that we have to implement. Maybe we can have a deeper look here. I just press Control on my keyboard and the left mouse button to get into the code. And here you see we have this method defined here. So now it is added, but well, not yet implemented. But regarding the actual implementation, let's just have a quick look here again to the service. Here in the article service, we have a constructor where we inject the article repository, right, and then call the GetArticlesAsync method. And in the end, we do pretty much the same thing in our query handler, right? We just separated the concerns. It is not tightly coupled, all that stuff. We can really just focus on getting only the articles here in this query handler, and the service would grow when we implement all the other CRUD operations, right? So this is the big difference in essence. And in here, again, first, let's add the repository. So we have private read-only iArticle repository, call this article repository like that. And here with control and period, we generate the constructor. There it is. And here we can again make use of that. So let's just say our articles now is await article repository, get all articles async, and then in the end we just return the articles, and that's it. And the beauty now really is, I know I'm repeating myself, but I have to emphasize this. This is everything. Things won't grow when we have more queries, more commands, and so on, right? So we can just focus on getting all the articles, and when we want to change something, then we just change this one little request, this one little query here, and we're done. We do not destroy the whole application or interfere with other implementations, all right? Okay, so that's it actually already for our very first query. And in the next lecture now, we will just make a few changes on the client to make use of this new request. So let's do that next. All right, so now from the application project, we go to our server project, and here you see it already. There is our articles page, and we still inject the article service. And now we change that by injecting another object that comes from the Mediator package. But first, let's have a quick look here in the application project, and then the dependencies, we see the Mediator package, right? And regarding the projects, we only have a reference to the domain, our clean architecture, right? But now here in the server project, it's the presentation layer. We have no Mediator package, but we have the project's infrastructure, then here application, and with that then also the Mediator package. So you really have to pay attention here, because it could be the case that you have to rebuild your solution first, so that Visual Studio knows that you also have the Mediator package here referenced in your presentation layer. Just a little hint here, pay attention there, might be a pitfall for you. In my case, it was really the case when I implemented that sometimes the Mediator package was not recognized, and I was wondering, why is that? Simply rebuild your project, and then thanks to all the references, the project references here in the end, we should, or it should be available. So let's just try that. The object we need is the so-called sender, the iSender interface. So here, let's say add inject iSender, call this, nope, that's not it, iSender, and then sender, and here now you see it with control period, it is suggesting using Mediator, and this is exactly correct. But let me change that and go to the imports Razor file and add the reference here now, and remove the article service. So here now we have the iSender available, and down here you see the error already. We do not want to use the article service anymore. What we want to use is the sender object, so sender and then send, and this is our Mediator object, right? This sender thing here. And what you want to send is, well, a request. So in the end, a query or a command. And as you can see here, we need some object, and if you want also a cancellation token, but in our case, let's just use a request, and this then would be a new get articles query like that. And then of course, again with control and period, we add our reference, it's here, and let me again just move that to the imports Razor file like that, and we're done. It is recognized, we do not need the service anymore, and that's everything for the most basic example I can think of. So let's just save everything and run our application. Here we are again. So now let's just go directly to the articles. It is loading, and here are the articles. So now let me just clean up that a little bit. So here, no delay anymore, and really just remove the interface and also the article service here. Restart the application. Now something is missing, of course. So here we registered the article service, so remove that. Now this is gone, and again run the app. It is rebuilding. Let me just do that one more time. There it is, and no service anymore. We're using a query to get our articles, and that's it. Not that hard actually, I think, but again, this is just the most basic example. If you have questions, as always, please ask them in our beautiful community. And now the next step is to do a lot more. We want to use more queries, more commands, or any command at first. So let's implement all the CRUD operations for our articles in the next step. See you there. Wow, you made it all the way here. That's awesome. It's clear you've got what it takes to dive into the full Blazor and Clean Architecture Masterclass. This free preview is just the beginning. There is so much more to learn to really master Blazor and Clean Architecture and build amazing web applications. Remember, the first 100 people get the lowest price ever, so don't wait. Click the link in the video description below, use the coupon code, and let's keep learning together. Can't wait to see you in the full masterclass.